so this next example is almost identical to what we just did. So we're having a box that's hanging down with a certain amount of newtons, and it has two different angles as shown, and we're going to find the tension in each of these cables. So why did I do that problem? Well, this is what you would see it as. So the idea is we'll have something called static equilibrium, which means that if we add all of the vectors, we will still get that 0, 0. And that's called static equilibrium. So if you ever were in physics or are going to be in physics, you might be doing something like this, where we'll be adding the vectors. So the idea is we're going to be having these vectors that we're going to add together here. So we know that this is kind of our coordinate plane like so. So we'll kind of think of these red dashes as a coordinate plane, and we're going to be doing the same thing. So the first thing is to note that this angle and this angle are both 46 degrees. This angle and this angle are the same because there are parallel lines cut by transversals, and they are alternate interior angles. So those would be giving us those angles, and this is identical to the same problem. So if you think about it, we're going to have your ux's, u sub x, v sub y, v sub x plus wx is equal to 0, as well as u sub y plus v sub y plus wy. Your y components is also 0. So when we do this, we're going to get two equations. And you're going to follow through with your same SOHCAHTOA for all of those, just like we did on the last example. So I'm not going to walk through every step of this, just because it's going to be identical to what you did before. But we have all of these triangles. Again, if we consider this as a v, this is a u, and this is a w vector, we have your negative u sub x, u positive u sub y. We have both positive v y and positive v x. Sorry, vy. Sorry, yeah, your vx, yeah, my bad. And then we have, this is the magnitude of v, this is the magnitude of u, this is the magnitude of w. And notice how the angle is 0, so you don't really need much else. When you set these equations up, when you follow through that, by the way, in this case, we would get that the x is 0, the wx, because it's not moving left or right, but your wy is actually negative 425 because it is the distance or the same as the magnitude going downward. So because this is 425 as showed here in newtons, it's in the negative direction, so this will be negative 425 as that. And we know, again, that the magnitude of that is also positive 425. So just things to note when you're doing this. If we set up that first equation, we will get negative the magnitude of u cosine of 46 degrees, just like we did before. So again, you would look over here and do SOHCAHTOA. So if you wanted to do that would be my u sub x. So if you're finding that, you're finding the u sub x here, so you're using this, which would be the negative, and then you're using this angle and going through that. Then for the next part, the v of x, we're going to be using this, which is positive. We're using this angle. We're still using cosine. So in this case, it'll be the positive magnitude of v and then cosine of the 38. And then plus, well, we know that that is 0 and it's equal to 0 like we set up here. So we're just kind of going through this list here. That's what this first equation is going through. So our second equation is doing the u sub y, v sub y, w sub y, which are the y components. So in this case, when we look over here, the y components, we are going to be using this, which is positive. So it should be the positive magnitude of this, and then instead of cosine, it will be in fact sine of 46. This y value is again positive, so plus the magnitude of v and then sine of 38 degrees. And then plus, well, we know, or it's actually a negative 425 is equal to 0. So now we have those two equations, and we will solve those using a graphing calculator. So let's move that up here. Just remember, we're going to say like the magnitude of u is x. So just let the magnitude of x, so the magnitude of y equal x, and then let the magnitude of v equal y for simplicity's sake. So we have negative cosine of 46 degrees x, and then plus the cosine of 38 degrees y is equal to 0, because those would be 0. And then we'd have the positive sine of 46 degrees x, and then positive sine of 38 degrees y is equal to a positive 425, because we will add this to the other side. And then we would solve this for x and y, which if you do that, I'm not going to walk through the same calculator part where you should have done before, but you should get that x is the magnitude of u, which is about 336.7, and then you're going to label it as newtons. So that'll be my first one when you use the graphing calculator to find this. So use that TI-84 and the matrix at 2 by 3. And then we are going to get our next answer of y is the magnitude of v in this case, which will be about 296.9 newtons as well. So again, very, very similar. It'll be almost identical to what we did the last one. That's why I didn't go through every step for above setting it up. But the idea is you should get those equations using SOHCAHTOA and just simplifying them. It's just a lot of the basic trig stuff with little gross looking stuff. If you really want to try one of these on your own, I'm going to have you do that. I'm going to pause it and have an answer shortly. So if you walked through that, which is a long process, you should have got these two equations, make them x and y, and then use a calculator to get that. Again, this would be 0, 0. You have your x and y. So in this case, your x is negative. This is your y is negative. Both are positive over here. So just make sure you walk through that, drawing the triangles and so forth. Notice how it gives you the 16 degrees and the 25 degrees, so you don't have to use those other angles.